What if everything you've been told about hunger is incomplete? What if skipping meals doesn't immediately weaken the body, but instead activates a hidden biological program designed for survival, clarity, and repair? Imagine going 7 full days without food. Not as an experiment in willpower, not as a trend, but as a window into how the human body truly functions when constant feeding stops. For most people, the idea alone triggers fear. We've been conditioned to believe that hunger is dangerous, that energy disappears the moment food does, and that the body begins breaking down almost immediately without regular meals. But human biology did not evolve in grocery stores. It evolved in uncertainty. And because of that, the body carries systems that only reveal themselves when food is absent. This video is not encouraging extreme behavior, nor is it offering medical advice. It is an exploration based on established research of what scientists have observed inside the body during an extended fast of up to 7 days. Understanding these mechanisms does not mean they are appropriate for everyone. In fact, for many people, they are not. But understanding them changes how we see hunger, energy, and the intelligence of the human body itself. When you stop eating, the body does not panic, not at first. For the initial hours, everything feels deceptively normal. Your bloodstream still carries glucose. Your liver releases glycogen, stored sugar reserved specifically for times when food is unavailable. This system exists for one reason: to bridge the gap between meals. In modern life, we rarely notice it because food is always nearby. At this stage, hunger is mostly a signal, not a crisis. The stomach contracts. Hormones announce that eating is expected, but metabolically, the body remains in familiar territory. Insulin rises and falls. Energy output remains steady. This is the phase most people experience during intermittent fasting, and it rarely reveals anything extraordinary. The real transformation begins when those glycogen reserves run low. Usually somewhere between 18 and 24 hours, the liver's stored glucose is nearly depleted. This is the moment where the body must adapt or fail. And failure is not part of the design. Insulin levels drop sharply. Fat stores begin releasing fatty acids into the bloodstream. The liver converts those fatty acids into ketone bodies, an alternative fuel source specifically capable of sustaining the brain. This shift marks the entrance into ketosis, a metabolic state humans relied on repeatedly throughout evolutionary history. As this transition unfolds, many people experience intense hunger, fatigue, dizziness, or irritability. This is not damage, it is recalibration. The nervous system is adjusting. Hormonal signals are being rewritten. The brain is learning to operate on a different fuel. Interestingly, some people report the opposite: heightened alertness, sharper focus, or a strange sense of clarity. This is not placebo. As insulin drops, norepinephrine rises, a neurotransmitter associated with vigilance and attention. From an evolutionary perspective, this makes perfect sense. When food is scarce, the organism must become more aware, not less. By the end of the first day, another subtle change begins. The digestive system slows down. Energy that was once devoted to processing food is now freed. The body starts reallocating resources away from digestion and toward internal regulation and maintenance. Before we go deeper into what the body does next, make sure you're subscribed. You won't want to miss what happens by day 3. Day 2 often challenges expectations even more. Instead of hunger intensifying, it frequently fades. The body has now largely transitioned to burning fat and ketones as its primary fuel. Blood sugar stabilizes at a lower, more consistent level. The roller coaster of spikes and crashes caused by frequent eating disappears. Ketones now cross the blood-brain barrier and supply a significant portion of the brain's energy needs. Unlike glucose, ketones provide a slow, steady fuel. This is why many people describe a calm, focused mental state during this phase. Thoughts feel less scattered, emotional reactivity softens, mental noise quiets. There is also an emotional shift that researchers have linked to changes in serotonin and dopamine signaling. These systems regulate mood, motivation, and reward. Some individuals report feeling emotionally neutral, unusually calm, or quietly content. This is not mysticism, it is neurochemistry responding to metabolic change. Behind the scenes, the body is making conservative choices. Muscle tissue is largely protected during early fasting. Protein breakdown is minimized. Metabolism slows slightly, not as a sign of harm, but as a strategic response. The body is conserving energy while maintaining essential function. Around the 48-hour mark, a deeper process begins to accelerate. Autophagy. Autophagy is the body's internal recycling system. Cells begin breaking down damaged components, dysfunctional proteins, and worn-out structures, converting them into usable fuel and raw materials. This process was formally described by Japanese scientist Yoshinori Ohsumi, whose work earned a Nobel Prize. Autophagy is not a detox trend. It is a fundamental biological mechanism involved in cellular health, immune regulation, and longevity. Under normal eating conditions, it runs quietly in the background. During prolonged fasting, it becomes more active. This shift represents a change in priorities. The body temporarily moves away from growth and toward repair. Energy is no longer spent digesting food or building new tissue. It is spent maintaining quality, efficiency, and survival readiness. By the end of the second day, the body has entered a state that feels very different from ordinary life. Hunger is no longer dominant. Energy feels quieter but more stable. The system is no longer reacting, it is adapting. And what happens next is where the process becomes truly remarkable. Day 3 is where fasting stops feeling like deprivation and starts behaving like transformation. By this point, the body no longer treats the absence of food as a short-term inconvenience. It recognizes it as a serious environmental condition and responds accordingly. This recognition triggers a deep metabolic shift that changes how nearly every system operates. One of the most important changes happens in energy management. Fat has now become the dominant fuel source, not just for muscles, but for the brain as well. Ketone production in the liver reaches a level where ketones supply the majority of the brain's energy needs. This is no longer a transition phase, it is a new operating mode. As a result, many people report that the intense hunger of earlier days is almost entirely gone. Not suppressed, not ignored, simply absent. Appetite-regulating hormones like ghrelin decrease, while satiety signals stabilize. The body is no longer asking for food. It is conserving and optimizing. At the same time, insulin levels are now extremely low and stable. This creates a biochemical environment that allows fat breakdown to accelerate without resistance. Stored fat is released efficiently, providing a steady stream of fuel. Unlike glucose metabolism, which fluctuates rapidly, fat-based metabolism is slow, consistent, and remarkably calm. This is why day 3 often brings a paradoxical experience. Physical weakness paired with mental clarity. Physically, movements may feel slower. The body is conserving energy, heart rate may drop slightly, core temperature can decrease. These are not signs of failure, they are signs of efficiency. The body is doing less, but doing it better. Mentally, however, something unusual often emerges. Many people describe a sense of sharpness, focus, or emotional distance from stress. This is not adrenaline. It is neurological adaptation. Ketones do more than fuel the brain. They also reduce oxidative stress in neurons and alter neurotransmitter balance. Research suggests that ketone metabolism increases GABA activity, a calming neurotransmitter, while stabilizing glutamate signaling, which is often associated with anxiety and overstimulation. The result is a quieter mind. This mental shift has historical significance. Early humans who experienced prolonged food scarcity needed to remain calm, observant, and strategic, not panicked. A nervous system overwhelmed by stress would have been maladaptive. Day 3 reflects this ancient neurological design. Another major change occurs in inflammation regulation. Studies show that prolonged fasting can significantly reduce markers of systemic inflammation. This happens because insulin is low, oxidative stress is reduced, and inflammatory immune signaling is temporarily downregulated. The body shifts away from defense mode and toward maintenance mode. Interestingly, white blood cell dynamics begin to change around this time. Old or damaged immune cells are broken down, while signals for regeneration increase. Some researchers believe this contributes to the immune reset observed after prolonged fasting, particularly when followed by careful refeeding. At the cellular level, autophagy intensifies. Cells increase the breakdown of damaged mitochondria, misfolded proteins, and dysfunctional components. This is not random destruction. It is selective cleanup. The body is removing inefficiencies that would otherwise accumulate over time. This is why autophagy is often linked to longevity research. It represents a quality control phase where cells prioritize function over growth. Day 3 is when this process becomes system-wide rather than localized. However, this stage is not universally comfortable. Some individuals experience headaches, dizziness, or sleep disturbances. Electrolyte imbalance becomes a real risk here, particularly sodium, potassium, and magnesium. These minerals are essential for nerve signaling, muscle contraction, and heart rhythm. Without adequate hydration and mineral intake, the nervous system can become unstable. This is one of the reasons extended fasting should never be romanticized. The same mechanisms that allow adaptation also create vulnerability if basic physiological needs are neglected. Still, when supported properly, day 3 represents a remarkable moment. The body stops reacting and starts reorganizing. Energy that was once consumed by digestion, absorption, and constant metabolic switching is now redirected toward repair. Tissues begin recovering. Inflammatory processes quiet down. Hormonal signaling becomes simplified and efficient. Many people report that by the end of day 3, fatigue decreases rather than increases. The body has learned the rhythm. It is no longer fighting the condition, it is working within it. Psychologically, this stage can feel strange. With hunger largely absent and mental noise reduced, there is often an increased awareness of internal states. Thoughts feel slower but deeper. Emotional reactions lose urgency. Some describe a sense of detachment, not numbness, but distance. The ability to observe rather than react. This psychological shift is not accidental. When survival is uncertain, emotional efficiency matters. The nervous system prioritizes clarity over intensity. From a biological perspective, day 3 marks the point where fasting stops being a stressor and becomes a structured survival state. The body has crossed from short-term response into long-term adaptation. And once this threshold is crossed, the changes that follow are no longer subtle. They become systemic. By day 4, expectations often collapse. Most people assume that the longer food is absent, the weaker the body must become. Logic suggests exhaustion should peak here. Yet for many, the opposite happens. Energy begins to return not as explosive strength, but as a steady, grounded vitality that feels unfamiliar in modern life. This is not a miracle. It is metabolism settling into efficiency. By day 4, the body is fully adapted to fat-based fuel. Ketone production is high and stable. Blood glucose remains low but sufficient. There are no spikes, no crashes, no urgent demands. Energy arrives evenly, quietly, without drama. This stability is what many people mistake for extra energy. In reality, it is the absence of fluctuation. The body is no longer wasting resources switching between fuel sources. It is operating in a single coherent mode. At the cellular level, mitochondria, the energy-producing structures inside cells, become more efficient at burning fat. This improves the ratio of energy produced to oxidative stress generated. In simple terms, the body is making energy with less damage. This is one reason researchers are interested in fasting and metabolic flexibility. When cells learn to shift efficiently between fuel sources, they become more resilient to stress. They break down more slowly. They age more gradually. As physical energy stabilizes, neurological changes deepen. One of the most important shifts involves a protein called brain-derived neurotrophic factor, or BDNF. BDNF plays a key role in learning, memory, and the formation of new neural connections. Studies show that fasting can significantly increase BDNF levels in the brain. Think of BDNF as fertilizer for neurons. It does not create intelligence on its own, but it creates conditions for growth, repair, and adaptability. This is why many people describe enhanced mental clarity, creativity, or problem-solving ability during days 4 and 5. This state often feels like mental flow. Thoughts connect more easily, distractions lose their grip. The mind feels less reactive and more intentional. Again, this is not mystical. It is evolutionary. Early humans facing prolonged scarcity needed to think clearly, plan efficiently, and conserve emotional energy. A scattered, impulsive mind would have been dangerous. Fasting shifts the brain toward focus and coherence because survival once depended on it. Emotionally, this stage can feel surprisingly calm. With insulin low and neurotransmitter signaling stabilized, emotional highs and lows flatten. Dopamine signaling becomes less driven by immediate reward and more by internal motivation. Serotonin regulation shifts toward balance rather than stimulation. Some people describe this as emotional neutrality. Others call it peace. What matters is that emotional noise decreases. Reactions slow down. There is space between stimulus and response. This space is not emptiness, it is control. At the same time, the body continues prioritizing repair. Autophagy remains active, particularly in tissues that accumulate damage quickly, such as the liver, immune system, and nervous system. Inflammatory signaling stays low. Insulin sensitivity improves further. Hormonal pathways simplify. White blood cell regeneration continues. Older immune cells are cleared. New cells are prepared for production once feeding resumes. This is why some studies observe immune system renewal after extended fasting cycles, especially when refeeding is gradual and controlled. However, days 4 and 5 are also where risk becomes more pronounced. Electrolyte depletion can intensify. Sodium, potassium, and magnesium losses increase through urine. Without replenishment, symptoms such as weakness, dizziness, irregular heartbeat, or confusion can emerge. This is not optional physiology. These minerals are required for life. This is why fasting beyond several days should never be approached casually. The same adaptations that create clarity and efficiency also reduce physiological margin for error. Sleep patterns may also shift. Some individuals sleep less but feel rested. Others experience fragmented sleep or vivid dreams. This is linked to changes in cortisol rhythm and neurotransmitter balance. The brain is operating in a different mode, and circadian signals adapt accordingly. Psychologically, days 4 and 5 often bring heightened self-awareness. With hunger quiet and mental chatter reduced, attention turns inward. Thoughts feel slower, but more deliberate. Emotional triggers lose intensity. Many people notice patterns in their thinking that were previously obscured by constant stimulation. This is why fasting has been used historically, not just for survival, but for introspection. When the body simplifies, the mind follows. Yet it is important to understand what this state is and what it is not. It is not enlightenment, it is not permanent, and it is not evidence that the body no longer needs food. It is a temporary survival configuration, optimized for scarcity. The danger lies in misinterpreting efficiency as invincibility. By day 5, the body is operating with remarkable economy. Fat stores are still supplying energy. Muscle tissue is largely preserved, but the risk of protein breakdown slowly increases if the fast continues without careful support. This is the edge of adaptation. The system is stable but fragile. It works beautifully within narrow parameters and poorly outside them. Respecting that boundary is essential. What happens next, whether the fast continues or ends, determines whether these adaptations lead to renewal or harm. And that transition is where the final phase begins. By day 6, the body is no longer experimenting. It is fully committed. At this stage, metabolic adaptation has reached its highest efficiency. Fat oxidation is maximized. Ketone levels remain elevated and stable. Inflammatory markers are suppressed. Autophagy continues at a high rate, systematically clearing damaged cellular components. From a purely biological perspective, the body is operating in a rare state one few people ever reach in modern life. This is why day 6 and day 7 are often described as strangely quiet. Hunger is minimal or absent. Energy feels even and contained. Movements are slower but deliberate. The nervous system is calm, not excited. There is no urgency. The body has accepted scarcity as the operating environment. Inside, repair processes dominate. Stem cell signaling increases in certain tissues. Immune cell regeneration pathways are primed. The gut lining begins preparing for future intake, even though no food has arrived yet. This is not starvation collapse, it is controlled conservation. However, this peak comes with a shadow. By day 6 or 7, the margin for error becomes very small. Glycogen stores are long gone. Electrolyte balance is fragile. Any disruption, dehydration, mineral loss, sudden exertion can destabilize the system quickly. This is where the distinction between adaptation and danger becomes critical. Extended fasting pushes the body into a narrow physiological corridor. Within that corridor, efficiency is remarkable. Outside of it, risk escalates rapidly. This is why medical supervision is strongly recommended for fasts beyond several days. One of the most serious risks at this stage is excessive protein breakdown. While the body preserves muscle remarkably well during early fasting, prolonged deprivation eventually forces it to extract amino acids from muscle tissue to support essential functions. If this process accelerates, it can weaken the heart, impair organ function, and reduce overall resilience. Another major risk is electrolyte imbalance. Sodium, potassium, magnesium, and phosphate are essential for nerve transmission and heart rhythm. During prolonged fasting, insulin remains low, causing kidneys to excrete more electrolytes. Without replenishment, arrhythmias, confusion, fainting, or collapse can occur. But the most dangerous phase is not always the fast itself. It is what happens when the fast ends. After 6 or 7 days without food, the digestive system is profoundly downregulated. Enzyme production is low. Gut motility is reduced. The intestinal lining is sensitive. When food suddenly returns, the body reacts strongly. This reaction is known as refeeding syndrome. When carbohydrates are reintroduced too quickly, insulin spikes. Electrolytes, especially phosphate, rush into cells. Blood levels drop abruptly. This can disrupt heart rhythm, impair breathing, and in severe cases, become fatal. This is why breaking a fast is not a celebration. It is a medical transition. Refeeding must begin slowly, small portions, easily digestible foods, fluids first, proteins and fats introduced cautiously, carbohydrates added gradually. The goal is not to satisfy appetite. The goal is to teach the body how to eat again. The gut microbiome, the trillions of bacteria that influence digestion, immunity, and even mood also reawakens during this phase. How you refeed shapes this ecosystem, sometimes for weeks afterward. Done carefully, refeeding completes the cycle. Done poorly, it can undo everything. When the transition is handled with respect, the benefits of the fast often become most visible afterward. Insulin sensitivity improves, appetite regulation resets, inflammatory responses remain lower, mental clarity lingers. But the most lasting effect is not physical. It is perceptual. After 7 days without food, eating no longer feels automatic. Hunger no longer feels urgent. The constant noise around consumption fades. Many people report a renewed sense of gratitude, simplicity, and awareness around eating. This is why fasting has never truly been about deprivation. It is about contrast. By removing excess, the body reveals what is essential. By eliminating constant input, the mind rediscovers clarity. The experience teaches something modern life often hides. We need far less than we think to function and far less than we think to feel alive. Still, this experience should never be romanticized. Fasting is not a shortcut to health. It is not a cure. It is not a test of moral strength. For some, it can be therapeutic under supervision. For others, it can be harmful. Biology is not one size fits all. The real lesson of a 7-day fast is not endurance. It is respect. Respect for the intelligence of the body. Respect for its limits. Respect for the delicate balance between stress and repair. The body is not fragile, but it is precise. When you listen carefully, it adapts in extraordinary ways. When you push blindly, it breaks. Understanding what happens during a 7-day fast is not an invitation to try it. It is an invitation to rethink hunger, metabolism, and resilience. And perhaps most importantly, it is a reminder of something easy to forget in a world of constant abundance. The human body remembers how to survive. And when given the right conditions, it remembers how to heal.